Hello. Last time I was working with Blender to make a exporter for animation data. And so today I'm going to try to get that imported into my engine. I don't know if we'll actually see animations moving in my engine today, but we'll definitely try to get a lot closer. So let's do that. Now, as I said, or I definitely mentioned before, I have to save animation stuff in some kind of long-term storage area. So I need to make the ability to do that. So I have this long-term buffer here, and then I also made a long-term buffer pointer. So with that, I can make a function, just a really rough rudimentary function that will get me some uh, pointer data from the game state. Or it'll give me a pointer to some data from the game state, if that makes any sense. I don't know where to put it though. I don't know, I'll just put it here. So it's going to be a static function. It's going to return a, I guess, I don't know, a byte, assigned byte pointer. I'll call it get, or I'll just call it allocate long-term memory. And then since it takes in a game state, it'll be pretty obvious that I'm getting it from the game state, I assume. And then you just really need to know how much memory do you need. And so all I'm going to do is just return. Oh, so here's something I definitely need to make sure I do. Let me come back to that. But when I initialize the game state, I might be doing this already, but I don't know. So here, so I don't need this anymore. But before I start reserving memory from there, I need to make sure that the states storage dot long-term buffer pointer initially at least points to storage points to that. And then you know what I should also do is keep track of how much long-term storage I have reserved. Actually, this probably need to be a 64, so we'll call it long-term buffer storage taken. That's a really long variable name, whatever. Yeah, so for now, it's just really basic, really rudimentary. I'm not worried about, what happens if I need to free memory. As of now, it's just all the memory I reserve is memory I get for the whole duration of the game. But of course, that's not going to be like that forever. So yeah, so that gets set to 0 automatically, so I don't got to worry about the thing there. So now here, I'm going to basically just return the state storage. Actually, no, I don't want to return that directly. So I need to make an S8 pointer. I'll call this just PTR, and that's what I'm eventually going to return. That is equal to the state storage dot long-term buffer pointer. Yeah, that's what I want. And then the state storage dot long-term buffer storage taken is going to increase by the amount. Can't spell amount. Okay, I did it, yay. And then I want to return that pointer. Oh, and I also want to increase, yeah, I want to increase this by amount. I think that does it. All right, so I can test that, I guess. So where I really need to use that actually is here, where I'm creating an animated. Why is it not showing up? There it is. So here where I'm basically just peeling off this weight and, well, actually it's right here. I'm just skipping past all the weights and the bone data, so I need to save that in a place. So that place will be probably in the animated mesh, texture mesh. At least for now. Where'd it go? There it is. Okay. So I need a float pointer for the weights. WAIGHT, yes. And then another one. I know the bones are actually integers, but everything, it's just from the exporter up to the GPU, it's all going to be used as it floats. So I think I'm going to just keep it as that for now. So that's that. And then I need to know how many vertices total. So then I can calculate how much size I need, how much space I need for that. And so let's now come here. And so then the mesh dot total vertices is equal to the total vertices. You know, I can just do this all at the end. It's a little cleaner that way. And then, yeah, so this here needs to change. So before I can do this, actually. All right, so this is where that new function is going to come in handy. So mesh dot weights. You know, I'm going to change that name actually, because they're not. It's not actually. But it's kind of an array. Keep it. I don't know. Okay, so anyway, that is now going to equal, and I cast this to a. I called it allocate long-term memory. So I'm going to pass in the address. Oh, no, I don't need the address. I just need to pass in game state. And then the amount of memory is the size of a float multiplied by total vertices. And then there's 4 weights per vertex. And then this will be same thing. Yeah, I really could just pack all 4 of those into an integer. Worry about that later. Okay, so then here is, so this is the positions, the normals, the texture coordinates. So I could just basically. What am I doing? There we go. Okay, so I have one that goes through 4, and then, so this would be not vertex pointer. Oh, wait. No, hold on. Oh, no, okay, that's okay. Kind of losing my train of thought here. So this is going to go 4 times, and then this. I don't need that at all. So I want this, but I don't need the. Okay, so I know what's going on now. So I need another one of these. I'll call this W pointer equals mesh dot weights, and then F32. I'll call this B pointer. Mesh dot bones. Okay, so then now here I want to. What am I doing? Can't keep anything straight. So I want to do W pointer B W pointer. Then eventually want to increase that. I know that, and then that's going to equal D pointer, and then I want to increase D pointer. Okay, I think I got that straight. And then I want to do the same thing, except for I want to use B pointer and B pointer. And then I don't need to do that anymore. Yeah, I have no idea if that's working. Let's now try to import this file that I exported from Blender and see if it can make sense. Create a new mesh. So I'm going to do this here. I'm going to say read file into buffer. I want to read tentacle dot unedited, right? Yeah. And I'm just going to read it into the temp storage buffer. And I'll just use the same variable for the file length. Let me see. Okay, so I'm just going to run that. I'm going to compile this. Hopefully it compiles. I did a lot of code. Nope. Cannot convert from U8 to S8. That's here. Oh, I did make the pointer at U8. Does that matter? I don't think so, because it just gets cast to whatever you need anyway. There we go. All right, so what am I looking at? So now I'm going to look at the temp storage buffer 2. Oh, it's already set up, which makes sense. So the first thing I put in there is the total number of bones. And then the next one should be poses, which is 3. So if I say, do the same thing, temp storage buffer plus 1. Wait. Is that 1, 3? Anyway, yeah, so yeah, 2 bones, 3 poses. And then I just got to hope all the other information is correct. So to do that, let's go ahead and start trying to peel this off here. Oh yeah, I probably want to use, just reset this here. All right, and then this will be the total bones, and that's equal to the same thing. In fact, you can copy all of that. Oops, let me recompile. Control B is right next to Control V, so that now needs to be total poses. Okay, so let me just double check that that's correct. Total bones 2, total poses 3. That is good. Can't remember what I put next after my thing. So I used should be a Python file somewhere. Oh no, that's not what I was looking for. Oh, there it is. Animation exporter. Okay, so I did the total bones, total poses, which is the same as the keyframes. Then I put in the actual keyframes themselves. So I should check that. That'll be easy to check. And then the inverse buying transform. So I could probably cast, that's just a big bunch of floats. I can probably cast those into matrices and check. So let me go back to, did I delete that debug point? Yeah, I did. So let's go back to here. Run that, and we're going to take a look at this TBS pointer. What? Oh, TSB pointer. And I wanted to look at it as if it were a pointer to a I guess it'd be a float, right? Okay, so that should be the first keyframe, 0, which makes sense. Wait, I did everything else as a float. Just double checking here. Oh, I closed Blender, never mind. Okay, so this is +1 and +2. Since there's 3 poses, that is not right. Oh, that's getting the thing there. Is that right? No, that's not right. Can't remember how to cast the pointer properly. Oh, this debugger's crap anyway. Actually, I just want to do this. So that's keyframe 1, and then that's going to be that same thing. Keyframe 2, keyframe 3. Can't believe doing this is faster than trying to just look at it through the debugger. All right. There we go. They are completely wrong here, but that is not because they are the wrong type. That is why. There we go. Okay, 0, 9, 23. It was actually 1, 10, and 24, but I start everything at 0 for the. I'm thinking it'll make sense to start all the keyframes at 0 for every animation. But we'll see. But anyway, yeah, that is correct. So everything it's so far is telling me that it was read properly from this file. So now the next thing is the inverse bind transform, which can be read as a matrix 4, I believe. We'll see. So matrix 4 IBT. Actually, this is going to be a pointer. Actually, maybe not. Maybe I don't have to do it this way. Maybe I can say that's equal to that. TSB PTR. Okay, does that work? Compiled. If I look at IBT, it's alphabetical, right? There it is. Yeah, it doesn't look out of the normal. I mean, it looks like the inverse of a identity matrix, except for that right there. But yeah, I don't know. I'm gonna say that's good. Okay, so assuming everything's good here, let's do this. Let's try to, so every animation, mesh animation, is more or less going to be a pointer. Yeah, because you're going to have to just change those on the fly. So let me think about this here. If you create animated mesh, so below, no, I'm going to say, yeah, below. I don't think I need to do this, below, above. I'm going to say static void create animated mesh. This time you have to provide the mesh animation as a pointer because it's going to allocate the memory for you, right? I don't know. Let's see. So then you need, for now I'm just going to do it by file name. So yeah. Okay, so all this is going to happen here, but this is not going to be that. This is going to be file name. Oh wait, hold on, I'm putting this in the wrong spot. Wait. Oh, hold on. Oh, okay, I'm calling this the wrong thing. That's what's going on. Create mesh animation. There we go. And then this should be capital N. There we go. We'll just put it in the temp storage buffer, and I need the file length. And this will be a UA pointer. Okay, so instead of total bones, okay, so all this is going to happen differently. Well, I'm going to keep it like that. Okay, so I need to calculate, before this, I need to calculate how much space to reserve on this. So let me do that here. So U32 total animation space size is equal to, oh wait, I need to do this after I read these things from here. Okay, U32 total animation size is equal to the total bones. So that I need, okay, so how do I think about this? Oh yeah, I could just look at what an animation is. Okay, so a bone is the size of a bone times the number of poses. Oh, this is complicated. Okay. Everything here changes. But not really. Okay, so it's whatever. It's a bone for every pose and the frame rate. I don't know. I feel like there's something I'm missing. Okay, so yeah, I'm confused because I don't think this is complete, and I'm trying to Whoops, whoa, stop. I'm trying to prematurely figure out like how big it's going to be, and I don't even know if it's done yet. So let me come back to that in a minute. Let me finish parsing everything from this file. That'll be good, because the file has the total bounds, total poses, and then it has the inverse bind transforms, which is a matrix. So I need a matrix array. Oh yes, that reminds me, I gotta add that in here. See, that's why I can't do this in order. But that, no, it doesn't change. Inverse bind transforms. Okay. So that makes things a little clearer, but I'm still confused. Okay. So yeah, so let me just do that. Let me say now, so there's going to be one inverse bind transform for every bone. So let's not make a for loop, but a for loop that goes through all of the bones. And when I get to a bone, yeah, so just basically I want to read all of those into a matrix. Okay. I know what's going on. I got it. So matrix 4 pointer, we'll call this IB inverse bind transfer, IBT. That's equal to, and now I need to start reserving memory from this thing, but I'd like to keep it all together. Okay, now I'm getting confused. So I need memory before I can fill it, but I can't get memory until I know how much to get. Oh, okay, I see what's going on. I know what's going on. I know what I need to do. So I could just create this like it ain't no thing. Okay, so maybe this doesn't need to take in that. I could, okay, yeah. I think this is gonna work. Wait, maybe. I don't know. We're gonna see. We're gonna see if this works. Mesh animation anim. That's just equal to nothing, and then I'm eventually going to return that. And then, so now I need to, okay, so now I can reserve memory for this, and I don't need to worry about all this other stuff. And then just assign these pointers to whatever memory I reserve. This is like a really unsecure way of doing this, but I don't care. That's how I'm going to do it for now. So I need, so it's all, okay, let me put this on the back burner for a second. So now that I know the total bones and the total poses, I can definitely calculate how much I need here. So I need the size of a bone. Okay, well this is easy. This is just matrix times total bones. This is the size of a bone times the total bones times the total poses. So that's going to be a lot larger, but not incalculable. So, okay, so what do I call this? Poses IBT. Okay, so there we go. Okay, so E32 total size. Actually, no, let me do this individually. So we're going to say poses size is equal to the total bones times total poses times however big one bone is. Right, I just called it bone. I did. All right, and then the inverse bind transform size is just the total bones times whatever the size of a matrix 4 is. And then the total size is those added together. So now I can say that anims dot, actually no, let me do this. Let me say U8, just whatever pointer is equal to allocate long-term memory, because I need to save this. This has got to stick around for a while. So we're going to pass in the game state. And we need to know how much, and the how much is total size. So now that I've done that, I can say that anims dot poses is equal to WPTR. WPTR will increase by poses size, and then anim dot, where'd it go? Inverse bind transpose. Is that showing up? There it is. Okay, I don't know, I'm wigging out today. Okay, so that is going to equal W pointer now. Oh, but I need to cast this, don't I? So that is a matrix 4 pointer now, and then you will pretend that you are a bone pointer, right? Poses. Yeah, I think that's it. Let me double check. So yeah, bone pointer, matrix 4 pointer. Okay, so that all being done, now I can go through here and what can I do? What can I do again? So going through the bones, and I'm just going to say IBT is equal to anim dot inverse bind transforms, just so I don't have to mess up this pointer. And then we're going to say that IBT is equal to, that's not equals, that's an equals. I need to cast it. And that would be TSB PTR. And then that has to increase by whatever the size of a matrix 4 is. There we go. Okay, so that should get all of the bones. No, wait, all of the inverse bind transforms. And I guess I can just always test that. That's a novel idea. All right, so we're going to say mesh animation ma is equal to create mesh. I really misspelled that. Animation. Make sure I fix that up there. There we go. All right, so we're going to create a mesh animation by passing in tentacle dot animdat. And first of all, does that compile? No. 543. Oh yeah, that would make sense. Hey, it compiles. Right, so that being done, it can now put a breakpoint here. Take a look at ma. I was hoping that would be 1, but maybe that's position is 0, parent index is 0. Okay, so let me do this. Ma dot poses 0. Oh wait, I'm looking at the, that hasn't been initialized yet. I'm testing the wrong thing. Oh, okay. So let me go back to there, and then I wanted to look at the inverse bind transforms. This first one here, and yeah, that's the same result I had earlier. So that's different matrix. I wish I could look at all these a lot easier, but oh well. Okay, so now I can look at ma dot inverse bind transforms at 1. And that's just completely all zeros. I don't know, that doesn't seem right to me. Yeah, it's not showing anything different. Okay, that's a little bit disheartening. Oh, you know what? I know exactly why. I'm not increasing IBT. It's just getting overwritten the same thing. So, okay, IBT also needs to just plus plus. That should do it. Okay, so let me, it's actually easier to test it here anyway. So if I recompile that and look at what IBT is. So IBT, oh, it's all zeros. That's not good. And it doesn't change. Oh, duh. Oh my god. Okay. I'm only getting memory for the, wait, what is W pointer again? Wait, I'm confused. Why am I so confused? Oh, okay, never mind. That's the memory for the whole thing. Okay. I'm tripping out. Okay. And then this is, yeah, okay, so that should be the right amount. Total size. What is the size? All right, let's try this again. So step in there. Okay, so that time it changed, but it got changed to gibberish. Weird. So I'm definitely doing something wrong. Okay, let me just double check. Total bones and total poses. Those are all good. So then poses size 192 seems reasonable. IBT size 128. 192 plus 128 is that 320? $520. Wait, no, I typed something wrong. 128 plus 192. There we go. Jeez. All right, so W pointer is going to be that many bytes. And so anim poses is W pointer. Okay, so that's IVT, all zeros, and then crap. Okay, so the second time it looks more correct. That's weird. So why would that be? What's TSP pointer point? That's so. Oh, you know what? I never increased it after. That's why. Alright, so there we go. That's still, well, it's not gibberish anymore, but it's. Oh, I guess, I don't know. I don't know why that would be like that, but. That's not. All right, I'm gonna continue and as if that's working, and then we'll regret that later. Oh yeah, I should actually double check that the order is correct. Why did I put this stupid texture? Oh my goodness, I'm losing everything. Okay, so texture. Oh no, I forgot. It's these stupid ones. Okay, so animated mesh exposure animation. There we go. That's what I wanted to look for. All right, so the order goes in this way. So, oh, the keyframes. That's why it's all weird. I'm not getting the keyframes, and then the animation, the inverse bind transforms, then the animation. Okay, that is why you check. So this is not ready yet. This has to be. Oh, so I need to add. I need to add size for this here. So this total bonds. This is going to be U32 pointer keyframes. Because that's going to be a variable size, and so now that has to be added to everything. So here is U32 keyframe size is equal to the total poses times size of a U32. No. Total poses. Yeah. Yeah. All right, so then the total size has to factor that in as well. All right, and then so before the anim poses can equal that, we have to say that the anim dot keyframes is equal to a U32 pointer version of W pointer. And then we need to say that W pointer is going to increase by keyframe size. Then the rest should be good. So that before here, I need to actually save those keyframes. So U32 pointer, I'll say keyf. Whatever. It's equal to anim dot keyframes for U32 I0. Yeah, I is less than total poses. KF, you know, I could just do this. KF at I is equal to Anyway, so that is equal to, I don't know. Oh yeah, I need to get the, where is it? This thing, that thing. And then TSB pointer equals 4. All right, let's test that. All right, so this is KF at 0. It's 0, which it should be. KF at 1 is not what I want it to be. Dang. What if I did? Wait, maybe it doesn't work that way. I think there's a way to do it though. If I say that it's a U32 pointer, no, U32 array of 2 things. U32 pointer array of 2 things, and then put KF. No, that doesn't work. I know there's a way to do it, I just don't know. But it doesn't look like to be the keyframes to me. So you know what I should do is be so much faster. Make sure I compiled it. Yeah, that's not what I want it to be. Definitely not what I want it to be. So I think, is it because it's a float maybe? F0 and then 9 and 20. Okay, so yeah, it's just trying to convert that to a U32 is messing it all up. So if I say now KF equals U32 version of F. How does that fancy it? Whoops. No. I don't even know if that works. Okay, so this is not working here. So you know, maybe it should just be floats because you can maybe like have half keyframes, but that's not. Yeah, whatever. I don't know. Wait, no, okay, so I'm gonna put this back here. Oh, okay, that's why. I gotta do it like that and then KF plus plus. There we go. That's all I was missing. I don't need to go back and overhaul a bunch of things. All right, KF at 1. Oh, it's still not what I want it to be though. Oh, because KF is not looking at that memory anymore. Or it's not looking at that memory yet. There we go. These. And then now. Oh, never mind. I don't know what I'm doing. Oh, you know what? Okay, I know what's going on here. I should look at it like that. Actually, I don't even need to. Let me just do that here. What? You sure? I use a capital F. How dare I? Oh, wait, I need to recompile. Of course, that messes everything else up. 539. And 545. That should be all. Okay, so then now I can do the same thing. Oops. Hey, there it is, finally. Okay, that was what I was looking for. Finally. And then, so that means that this should also be what I was looking for too. So let me see, let me just go ahead and try one. Yeah. Still, oh, I haven't even run that code yet, that would be why. Hey, there it goes, and it looks reasonable. And this one too looks reasonable as well. Yeah, I think that's about right. Great. Okay, so now all I have to do is get the bones out of there. Unfortunately, I think I'm out of time. I'm going to have to wrap it up here and do that next time. So I'm going to get the bones out of there, and then hopefully I can use all of that information to make the thing move on the screen. It's a lot of work. It's a lot of boring work, but it'll hopefully be worth it. Really excited for what's going to happen. Let me go ahead and stop debugging here, get rid of all of that. Go to Git here, add everything, commit. I'll just put more animation work and push it up. And while that's saving, I will sign out. Thank you, everybody. See you next time.